All right, Prop 31 is another construction proof. So, what we want to do, the goal is through a given point to draw a straight line parallel to a given straight line. So we have our straight line BC, we have our point A that is not on BC, and we want to draw the, as we know it today, the unique parallel line that passes through A and is parallel to BC. So, right, and this is, related, I should say, to Playfair's axiom, because Playfair's axiom, if you'll recall, is an equivalent statement of postulate 5, Euclid's postulate 5, but it's the much cleaner statement which says that through a given point, there exists exactly one unique line through that point that is parallel to the given line. So there's only one line that passes through there. That's not what this proposition says, but it seems to me that it's related. All right, and it's a pretty quick construction. It's not terrible. So right, how shall we do it? We'll say let D be taken arbitrarily. Arbitrarily. Can I spell it? Arbitrarily. I think that's right. On BC. And join AD. So I'll say, here's my point D. Put it over here maybe. So just any old point. It doesn't really matter. It can be completely arbitrary. It should be completely arbitrary. All right, what comes next? All right, so the next thing that he says, and I'll read what he wrote, and then I'll kind of give my equivalent statement. He says, on the straight line DA, oh right, I guess I haven't yet joined AD. I wrote that I was going to do that, and then I didn't do it. Let's do that first. There's AD. Okay. So on the straight line DA and at the point A on it, let the angle DAE be constructed equal to the angle ADC. So I'll just say construct angle DAE such that angle DAE equals angle ADC. Is that right? Yeah, ADC. And we can just say that because we had a proposition that allows us to copy-paste angles, if you like to think of it that way. So, right, let's see here. Let's do that. And what I'll do is I'll just kind of, because I want to make this somewhat precise, I'll make just like a little faint line here. Because, right, how do I want to do this? So, I got this nice, look at this thing. Look at this nice fancy compass that I got. It's like very legit. I was going through, I made the first handful of propositions with my sort of cruddier compass, and I didn't like it because it didn't really hold angles very well, and then like the pointy part was not pointy enough, so it was like slip sliding all over the place, and just ended up with some really funky looking semicircles. Took a lot of effort, so I was like, you know what, I'm just gonna invest in a nicer compass. And yeah, this thing is, it is very it's very serious. It is very sturdy. I love it. Okay, so right, I made that one, and then I'm just making this angle. I'm copy pasting this angle and trying to get a little bit of precision here is all I'm doing. It's close to equilateral triangle that I made. Right, and these will intersect. Perfect. And that intersection point forms the angle that we wanted. So I'll connect A, and I'll also kind of extend it through this point too. Just kind of like this. There we go. That's pretty close. Right? Those look pretty close to parallel. And, geometrically, they are parallel. The only reason they might not be parallel is if I, was a little bit imprecise with making that angle. Right, and that's really kind of the end of the proof, like, or the construction. We just now need to prove that this is what we need. So construct DAE, and maybe I'll say, just to keep kind of consistent with how Euclid did it, extend EA to F. So over here is E, and then over here is F. There we go. So, and then claim, which we need to prove. So I guess, yeah, maybe I shouldn't have said proof quite yet. I'm still constructing things. Claim is that EF, or EAF, is how I'll write it, just to kind of indicate that it's passing through the point A, because that was part of the requirement. EAF is parallel to BC. And now let's prove that. Yeah, now proof. All right. So, and it's pretty much a one-liner proof, and it follows from the construction and one of the previous propositions. So, which is basically this: since angle DAE equals angle ADC, by construction, the result follows. It's parallel to BC, and that comes from proposition, let's see, what did they say? They said 27. Yeah, that seems right to me, yes. Since this angle is equal to this angle, the lines are parallel. So, and that's what we needed to do. QEF.